All right, now let's go and look into some complex numbers. So complex numbers do come up in definitely precalculus. We're going to deal with them where we're going to get into a little bit with our polynomials. And then also once we learn kind of our vectors and kind of stuff like that. So it's going to get to some fun things, especially with like the polar coordinates and everything like that. So all right, so the main thing we want to understand is the imaginary units, right? The square root of -1 is going to equal a I. So what I always like to do in a problem like this is just remember you can always rewrite this as a -1 times a 49, right? So now we could break that up and do the square root of -1 times the square root of a 49. Well, the square root of -1, we said is our imaginary unit, which is I, and the square root of a 49, which is going to be a 7. Now, typically, we write the I kind of like, even though it represents the square root of -1, we still write it as like a variable. So we'd write this as a 7i. Now in this example, we're just going to simplify this just kind of like a radical, right? So the first thing I can do is kind of like take out the negative, right? That's taking the square root of a negative and just kind of rewrite this as a 6i times the square root of 12, right? To kind of see what I did rather than just, writing a negative and then saying that's I, you can just kind of like take that out. Now I can go ahead and rewrite the square root of 12 as a 4 times 3. So 6i times the square root of 4 times 3. Now I can take the square root of 4, which is going to be 2. I can't take the square root of 3, so that's going to remain in there. And then 2 times 6 is going to be a 12i times the square root of 3. Now, in this example, we basically have two binomials multiplied by each other. So the only important thing to recognize here is if we have the square root of -1 is I, then if we were to square both sides, we'd have an I squared. Well, I squared then, what's the square root of the square root of the square root of -1 squared is what? Just equal to -1. So it's important to recognize this relationship. I squared is equal to -1. Because when I go ahead and multiply this, when I go and apply my distributive property, what I'm going to get is a 7 times 3, which is a 21, a 7 times 3i, which is a 21i, a 3 times -1, which is a -3i, and a -I times a positive 3i is going to be a -3i squared, right? So now we have here is I squared is a -1. So let's go and combine our like terms. So 21, you can think of the I as kind of like a variable as well, like, x plus x is 2x. So a 21i minus a 3i is going to be a positive 18i. I squared is -1, so -3 times -1 is going to be a positive 3. And now I can combine the 21 plus a 3, so that's going to equal a 24 plus an 18i, and therefore we're all set. And then just like we rationalize the denominator with our radicals, we can rationalize the denominator with our I. Basically, we don't want to divide by a irrational number. We don't want to divide, we don't want to divide by an imaginary number. So what I can do here is just multiply by I on the top and bottom. Make sure though you put this around parentheses because we're going to have to distribute that. And when I do this, I'm going to get a 3i plus a 7i squared is all over a 7i squared, okay? Now, remember, I squared is -1, so -1 times 7 is going to be a -7, so therefore this is going to turn into a 3i minus 7 divided by a -7. Now, again, do not distribute or do not cancel out those -7s. You have to divide this -7 into both of these terms. So when you do that, you get a -3 I7s, and then therefore this is going to be a +1. Now, typically, we can go ahead and we can just go and write it like this, many different ways. We can definitely go write this like a -3/7 I. That just kind of looks bad. So let's go and fix that. So it'd be a -3/7 I plus 1. And same thing like that. In this case, we have kind of the exact same thing that we did before. Again, you notice here we have a binomial. So therefore we need to now multiply by the conjugate. So what I'm going to do here is I'm going to do, now big mistake that students will make is they'll say this is the conjugate. That's not the conjugate actually. So this is actually kind of confusing. You want the I or whatever you're trying to do to be your conjugate. So what we're actually going to need to do in this case, you can leave it like this, but I always like to just like rewrite this. So -2 plus a 3i. So I'm just going to rearrange this so my I is going to be after, right? So therefore I can say this is -3. Oh, a plus bi. There we go. Sorry about that. I was kind of remembering. A plus bi. So typically we always like to write the constant in front of our variable with that. So therefore actually I'd rewrite this as a 1 minus a 3/7 I. Okay, and that's exactly what you're going to want to do here as well. You can do a -3 plus a 5i. Okay, now we can multiply by the conjugate here. And so what happens here is when I multiply by the conjugate, what I'm going to get is a -3, and therefore that's going to be a minus a 5i. And we're going to do that on the top as well as on the bottom. Okay. So now let's go and see what's going to happen up top here. We're going to have a 6, let's see, plus a 10i. Negative 3 times 3i is going to be a negative 9i. And 3i times negative 15i is going to be a negative 15. And that's going to be an I squared. Okay, now this is going to be all over. Now remember, this is the difference of two squares, right? Negative 3 times negative 3 is a positive 9. 5i times negative 5 is going to be a negative 25 I squared. Okay, so that's cool. Now again, I squared is negative 1. Negative 1 times negative 15 is going to be a positive 15. So I can add those up together. 6 plus 15 is going to be a 21. 10i minus a 9i is going to be a positive I. So I can say plus I. And then over here, we have an I squared, which is negative 1. So negative 1 times negative 25 is now a positive 25. 9 plus a positive 25 is going to be a 34. Okay, so again, now we can just kind of distribute this. So I can do a 21 over 34 plus a 1 over 34i. And then last but not least, also just like we kind of worked on, you can also like add and subtract your terms, right? So just trying to, a lot of times when you're thinking about this, make sure you're just combining, like if they have an I, you can add and subtract them, right? So let's go and apply subtraction here. So a 6 minus 2 minus a 9i, and then plus a negative is really just the same thing as minus a 1 and, plus a 4i. And now I can just kind of group things together. So 6 minus 2 minus 1 minus a 9i plus a 4i. So basically what I'm doing is just writing them together. So 6 minus 2 is going to be a 4. 4 minus 1 is going to be a 3. Negative 9i plus a 4i is going to be a negative 5i. And therefore, that would be your simplified term. Again, you always want to write it in that a plus bi format.